In the previous lesson, we learned about the new homologous series called the alcohol, and they contain this functional group called the hydroxyl group. So this hydroxyl group contains an oxygen and a hydrogen. And we also take a look at the general formula of alcohol. There is CN, H2N plus 1, and the hydroxyl group called the OH. Then we also take a look at the structures of alcohol containing 1 carbon atoms all the way to 4 carbon atoms, and they are named methanol all the way to butanol. So we saw the full structural formula of these 4 alcohols. Then we also describe the properties of alcohol, the chemical reactions that it can undergo. So like alkane and alkene, it can undergo combustion in the presence of oxygen to produce CO2 and water. It can also undergo another reaction called oxidation, okay, with the help of oxidizing agent called your potassium manganate. It can also react with potassium dichromate. So during the oxidation of ethanol, for example, the acidified potassium manganate will turn from purple to colorless. For potassium dichromate, acidified potassium dichromate, it will turn from orange to green. So the OH group in the alcohol will be oxidized to form carboxyl group in acid. So if you notice, from one oxygen atom, there is an addition of one more oxygen to become 2 oxygen. So that is why this is an oxidation reaction from hydroxyl group to carboxyl group with 2 oxygen atoms. Then we also take a look at the 2 methods to prepare ethanol. Okay, so this is about the formation of alcohol, in particular ethanol. So we take a look at the catalyzed addition reaction of steam to ethene. So this is your hydration. And if you recall the condition for this reaction, 300 degrees Celsius, 60 atmospheric pressure, and it requires a catalyst called phosphoric acid. Okay, so this is one addition reaction. And then we also take a look at fermentation of glucose to form ethanol. So we are talking about how to manufacture ethanol specifically. So for the fermentation of glucose, for this reaction, we will need a condition of 37 degrees Celsius, and then we will need the microorganism called yeast. Okay, during this process, we will mix glucose, yeast together at 37 degrees Celsius to form ethanol. So once it reaches 15% ethanol, the reaction will stop because the yeast will be killed by the ethanol, high content of ethanol. Okay, so this reaction will never go to 100%. So to separate ethanol, this 15% ethanol and glucose, you will use fractional distillation. Okay. Then lastly, we also take a look at the uses of ethanol. What are the different uses of ethanol? So why do we need to manufacture ethanol? Because it can be used as a fuel. It is also used as a beverage. Moving on from alcohol, we will take a look at the last homologous series called the carboxylic acids. So for carboxylic acid, as we have seen just now, it contains 2 oxygen atoms. Okay, C double bond O. Right? So this carboxylic acid is a homologous series itself, contains this carboxyl group, C double bond O OH. And we also take a look at the full structural formula of carboxylic acid, containing 1 carbon atom all the way to 4 carbon atom. So we'll take a look at the simplest form where they are all straight chain. And the third one, as the name suggests, it is an acid. So it is weak acid, and it can undergo reactions like all other acids. So it can react with carbonates, base, and metals. Okay. Then we also re-look at this learning objective where ethanoic acid is formed from ethanol. So earlier on, we talked about ethanol being oxidized by oxidizing agent to ethanoic acid. So we'll take a look at it again. And one new reaction will be the carboxylic acid can also react with alcohol to form a new functional group called an ester. So we will take a look at it. Okay, and of course the last part, why do we need to form ester? Because there must be some uses of it. Okay, so let's take a look at page 17 of your notes. Alright, so I would like you to add on one more column here, which is the full structural formula. Okay, add on to your notes. Right, so we start off with the first member in the series. So the first member in the series, okay, the name is methanoic acid. So once you see the word meth, okay, the prefix, it means one carbon atom. Okay, so for this methanoic acid, we know that it has a functional group of COOH. Okay, so we know that carbon is in group 4, and this carbon here already has 3 bonds. Okay, so the remaining bond will be with the hydrogen. So the molecular formula for methanoic acid is HCOOH. Okay, so structural formula will be the simplified version of full structural formula. Okay, so it doesn't show the bond, alright, but it shows how the atoms are being placed in the molecule. Okay, moving on to the next one will be 2 carbon atoms called ethanoic acid. Okay, so likewise, it also has one functional group, that is the carboxyl group. Okay, now in this case, it says that this ethanoic acid has 2 carbon atoms. Okay, so I will need to draw one more carbon atom, and this carbon atom will be bonded to 3 hydrogen atoms. Okay, so the formula, the molecular formula is CH3COOH. Likewise, for the structural formula, it is also CH3COOH. Okay, then moving on to the next group. Okay, I would like you to try the remaining ones yourself before you take. So below ethanoic acid is 3 carbon atom. Okay, it will be called propanoic acid. So at this point, I hope you can see that the name is always with oic acid, oic acid. Okay, so same thing, I will always draw the functional group first. It has 3 carbon atoms, so I will draw second one and the third one. And I fill it up with hydrogen atom. So for this, the molecular formula will be telling me all the carbon atoms, the hydrogen atoms, and followed by my functional group. Now here is something different. For the structural formula, okay, first of all, since it's a simplified version, right? So I will first write down CH3, okay, and then CH2, and of course, lastly, my functional group. Okay, so structural formula shows how they are being bonded, okay, without me drawing all the bonds out clearly. Okay, moving on to the last one. Okay, 4 carbon atoms. The prefix is butanoic acid. Okay, same thing, always draw the functional group first. Okay, I have 3 more carbons to draw, so I draw 3 more, and I fill it up with hydrogen atoms. Okay, so molecular formula shows me all the carbon atoms except for the functional group. Similarly, this is CH3, this is CH2, and then this one also CH2, and of course the functional group. So this is the structural formula. So if you take a look from one member to another member, it is plus CH2 plus CH2 plus CH2. So members in the same homologous series, they differ by one another with each other with CH2. So it's the same. It's the same for alkane, alkene, alcohol, and carboxylic acid. Okay, so if you compare the formula now, just take a look at the molecular formula. Okay, I want you to try to deduce the general formula. So organic chemistry, they like to give you a homologous series, and then they ask you to deduce the general formula. So we take a look at the molecular formula, okay, keeping the functional group. Keeping the functional group. Okay, so if I were to keep the functional group constant, okay, just take a look at this part here. how can I come up with a general formula, okay, for this carboxylic acid series? Okay, so please write it inside your notes. The general formula, keeping the carboxyl group the same, it will be CnH2n plus 1. And this N, okay, instead of starting from 1, it starts from 0 now. Okay, so if you take a look at methanoic acid is HCOOH. I already have one carbon in the functional group. Okay, so this carbon here will be 0. And if my N is 0, okay, I only left with one hydrogen, which is this one. Okay, so the general formula for carboxylic acids is CnH2n plus 1 COOH. So please write this inside your notes. Okay. Next, let's take a look at the physical properties of carboxylic acid. So for carboxylic acid, okay, they are all liquids at room temperature and they are colorless liquid. So for carboxylic acids, as I go down the series, boiling point increases. Okay, this is the same for all homologous series. As we go down, boiling point increases because molecular size increases. So when my molecular size increases, surface area will increase. Then the weak intermolecular forces of attraction will also increase between molecules. So for acids, okay, because they are all acids, right? They are soluble in water. Okay, so write down the definition of acid. So all acids are soluble in water because they dissolve in water to form H plus ions. Without the H plus ions, they will not be acids. Okay, and they follow the properties of other acids that we have learned so far. They will turn moist blue litmus paper red. So let's take a look at the chemical properties of carboxylic acids. So carboxylic acids, they are acids, so they will dissolve in water to form H+. However, they are weak acid. So because they are weak acid, their pH is about 3 to 4. Whereas for strong acid, their pH is about 1. So because they are weak acid, they undergo partial dissociation in water to form a low concentration of H+ ions. So please include that inside your notes. So what they do is, okay, for example, this is my ethanoic acid, okay, it will dissociate partially. So you will see this reversible arrow. Okay, it will dissociate partially to form low concentration of H+ and ethanoic ions. So this is what they call ethanoic ions. Now, when you see ions in the equation, you must have state symbol. Alright, when you see ions in the equation, you must have state symbol. Okay, so in this case, okay, I'm going to draw the structures of the acids. Okay, please include that inside your notes. Okay, so for my ethanoic acid, it will look like this. So always draw the functional group first, which is COOH. And then I have one more carbon to draw. So it will dissociate partially, reversible arrow, and I will form my H+ ion. And this is how my ethanoic ion look like. Okay, same thing, CH3, COO minus. Okay, so this particular hydrogen is acidic. Only this hydrogen will form H+. Okay, the rest of the hydrogen will not. Okay, so once this hydrogen is formed, okay, I will need to ensure that the charges are balanced. So this is +1 charge, this is -1. Overall, okay, overall this is neutral, 0 charge. Same as this molecule, 0 charge. Okay, so I must balance the charge and the number of atoms. And only this hydrogen is acidic. Only the highlighted one is acidic. So this is the hydrogen that gives it the acidic property. So we'll take a look at the chemical reactions of carboxylic acid. So whatever reactions that we see here, okay, they are the same reactions as all acids. So carboxylic acid will react with metal to form salt and hydrogen. So ethanoic acid, for example, reacts with magnesium, will form magnesium ethanoate. So this is the salt and hydrogen. Okay, so how is it like if I were to write the equation? So I will write down, okay, ethanoic acid CH3COOH, okay, plus magnesium. And then I will form magnesium salt. Okay, so you have seen earlier, okay, my ethanoic ion has a charge of minus. Okay, and now I have my magnesium which Mg2 plus. So I need 2 of this ethanoic ion. Okay, how do I write? Okay, it will be slightly different from what we usually learn. This time round, okay, my ethanoic ion is in front. So now my N ion is in front. I need 2 of them because my magnesium is Mg2 plus. Okay, then I form my hydrogen. Alright, so if I look at this equation, it's not balanced yet. I need 2 of my ethanoic acid. So this is the chemical equation. So all acid dissolved in water aqueous state, okay? And then magnesium is a metal, so it's a solid state. Hydrogen is a gas. And all ethanoic salts are soluble, okay? All ethanoic salts are soluble. This is how the chemical equation looks like, alright? So when I want to draw the structure, okay, it will be 2 of this, okay, times 2 of this. So moving on, next equation is carbonates. Okay, acids react with carbonates to form salt, water, and carbon dioxide. Okay, likewise, I will use ethanoic acid as example, reacting with carbonate, magnesium carbonate. Okay, so I'm going to write down the chemical equation. First of all, I have my ethanoic acid, which is CH3COOH. Okay, and then I will react with my magnesium carbonate. Magnesium carbonate is MgCO3. And it will form magnesium ethanoate. Okay, water and carbon dioxide. So I write water and carbon dioxide first. Okay, likewise, magnesium ethanoate. Okay, I will write the ethanoate first. Okay, so I will need 2 of my ethanoic ion to balance this magnesium. Okay, so this is the chemical equation. It's not balanced. I need 2 to balance this. Okay, if I fill in the state symbol, all acids, they are dissolved in water to form aqueous solution. Magnesium carbonates, all carbonates are insoluble except for group 1 and ammonium. So magnesium carbonate is a solid. And previously we mentioned all ethanoic salts are soluble. So this is aqueous. Water is liquid state. Carbon dioxide is gaseous state. Okay, so this is the chemical equation. Okay, I would like you all to try the next one. Okay, without looking at the answers, try to come up with the chemical equation yourself first. Okay, so for this one is CH3COOH plus magnesium hydroxide. I will form magnesium ethanoate and ion in front and H2O. Okay, so I want to balance this equation. Aqueous. All hydroxides are solid state except for group 1. Okay, and this will be aqueous. Okay, so this is the balanced chemical equation. Alright, so the first 3 reactions that we have learned so far, okay, they are the reactions of acids. Just that the formula of the salt can be different, where N ion is now in front. Only for carboxylic acid. Okay, so only for carboxylic acid, N ions is in front. Okay, then the next reaction will be reaction of alcohol. So this is the most important reaction for this whole topic. So put a star. Okay. So this is a summary of the chemical properties of carboxylic acid. Okay, it's a weak acid. It undergoes the reactions of all other acids They can react with metals, carbonates, bases. Okay, and the last part is something that's only specifically for carboxylic acid will be it can react with alcohol to give a new functional group called ester. Okay, then let's take a look at how to prepare ethanoic acids first. Okay, so recall in alcohol, okay, we saw that alcohol can be oxidized by acidified potassium manganate, okay, to form ethanoic acid. It can also undergo oxidation, okay, with the atmospheric oxygen to form ethanoic acid. Okay, so that is why when we want to ferment glucose, we must not let oxygen to come into contact. Okay, because once oxygen comes into contact with ethanol, it will become ethanoic acid. So during fermentation, there must not be any oxygen present. Okay, so if you notice, I have one oxygen atom initially, and now my carboxyl group, I have two oxygen atoms. Okay, so addition of oxygen. So this is what we call oxidation. Okay, for oxidation of alcohol by oxidizing agent, take note the equation is similar. The products are the same, just that your oxygen is in the form of bracket. Okay, so this is the difference between 1 and 2. Okay, now let's take a look at the next reaction of carboxylic acid. So the last reaction that carboxylic acids will undergo will be with alcohol. So carboxylic acid and alcohol, they will react with each other to form a new functional group called esters. Okay, so what are esters? Esters are sweet-smelling compounds found in fruits and flour, and that is why they smell so good. Okay, so to form ester, we will need concentrated sulfuric acid as the catalyst. Okay, and we will need to heat this reaction under reflux. So this reaction is called esterification. Okay, this reaction will require heating under reflux because this reaction is reversible. So I will explain later what does reflux mean. So if you take a look at the functional group, it's actually quite similar to carboxylic acid. Okay, for carboxylic acid, all right, this is the carboxyl group, and this hydrogen here is acidic. Okay, which means this will form H+. Whereas for esters, okay, for esters, instead of bonding to hydrogen, they will bond to a carbon. Okay, this one can be C or hydrogen. But the ester linkage will be like this. Okay, this COO, and then instead of a hydrogen, it must be with a carbon. Okay, so this is what we call ester group. So that is the difference. Carboxyl group, one is hydrogen. For ester, the one bonded to the oxygen is a carbon. Okay, so this reaction is formed with concentrated sulfuric acid. So inside your equation, please write down above your arrow is always the condition. Okay, and we heat under reflux. So what does reflux mean? Okay, reflux means constant boiling and condensation. Okay, so it's boiling plus condensation on repeat. Meaning I boil already, I condense, and I boil again, I condense, I boil again, and condense. Okay, why do we do so? Is because the reaction is reversible. Okay, so if I boil already, it can go back. It can go back to form the reactants. So I want to make sure that it really go forward. Okay, so that is why I boil and condense again and again. Okay, so during this process, okay, the two functional group will start to react. So the OH of the ethanoic acid will combine with the H. Okay, and these two will form H2O. Okay, so these two will form H2O, and then this compound and this compound here will join together. Okay, and then they will form my ester. Okay, so this is my ester linkage. All right. Now take note. Okay, it must be between the OH and the H of alcohol. Okay, it can never be like this. This is not correct. This is not correct. Okay, please do not tell me that it's the hydroxyl and the H is different. Okay, it is the OH of the carboxyl group, okay, and the H of the alcohol. So these two will come together to form H2O. All right, so this is what esterification is. And then, okay, let's take a look at the naming. So I started off with ethanol and ethanoic acid. Okay, I will form water. And this compound here is called ethyl ethanoate. Okay, so if you recall this portion here, okay, this is similar. I wouldn't say same, but I would say it's similar to this. Okay, recall this is your ethanoate ion. Okay, so this is similar. So I have the name ethanoate, and this is my ethyl group. Okay, comes from alcohol. Okay, so this is from the alcohol. This is from the carboxylic acid. So how to remember? Okay, I remember it as the A always in front of the C. The alcohol A will always be in front of the C. Okay, when I draw my compound, okay, so I can also draw like this. This is also correct. Okay, if I want to draw my ethyl group in front, it is also okay. That means I invert. This is correct. Both are correct. But both are still called ethyl ethanoate. Both are still called ethyl ethanoate. Okay, so the alcohol will always be in front of the C, carboxylic acid. Okay, but if you draw both of these, they are correct. Okay, so let's try out naming of the compounds. Okay, so I'm going to form ester between methanoic acid and ethanol. Alright, so let's try out the naming of the compound first. Okay, so I'm going to use alcohol, which is the ethanol. Okay, so my front part will always be my alcohol, which is ethyl. Okay, and then this part here is the carboxylic acid. Okay, so my back part of the naming will be methanoic becomes methanoate. So the name is ethyl methanoate. Okay, likewise, let's try the next one. Okay, I start off with methanol and ethanoic acid. So the front part will be methyl. Okay, the second portion will be ethanoate. Okay, I change it to ethanoate. Now, if you don't want to write the hyphen in between, it's also fine. Both are correct. Okay, so for the last one, same thing. I will have my ethanol. So I always write the name for alcohol first. Ethyl. So what do you think is the one at the back? It will be ethanoate. Okay, so this is how we do the naming for ester. Always the alcohol first, okay, followed by the acids. All right, so let's take a look at this part here. So to summarize, okay, we will always have the alcohol group in terms of the naming, and then we also have the carboxyl group here. Okay, so this is what we call ester linkage. Okay, once you see C double bond O, O, and this particular O is bonded to a C, okay, it means that it is an ester. Okay, so this is what we call carboxyl group. Okay, it is bonded to a H, and then for my ester, it's bonded to a C. Okay, so that is the difference. So the uses of esters will be found in food flavorings. Okay, they are used to make perfume to smell good. Okay, they are also used as nail polish remover. So that's why when you smell all the perfume, okay, they are very sweet smelling because of presence of ester. Okay, so they are also found in fruits and flowers. Okay, so to end off, okay, we'll try to practice drawing the structures. Okay, so I'm going to draw once, okay, the first example, and you pause the video to fill in the rest. Okay, so I will have my methanoic acid. Okay, I draw my functional group. Methanoic acid has only one carbon, so this is it. And then I draw the ethanol, draw the functional group first, and 2 carbon. The reason why I draw my functional group on the left side so that I can combine them easily. Something like this. So this will form water, H2O, okay? And when I combine them together, it will form like this. Okay? So this portion here is from my alcohol, okay? And then this portion here is from the carboxylic acid. Okay, the name of this will be ethyl methanoate. Okay, so I can give a question where I give you the product and I ask you to find the reactants. Okay, so I can work backwards. Okay, so try the remaining 2 examples. Okay, ethanoic acid means I have 2 carbon. Okay, I draw the functional group. And then methanol means 1 carbon. And I combine them together, called esterification. This will form H2O. Okay, and then I will have my product, which is this. Okay, my oxygen is bonded directly to a C. Okay, so this is what we call methyl ethanoate. Okay, so now I'm going to draw the product and then we work backwards. Okay, because sometimes the question can give you the product and ask you, what are the reactants to form this? Okay, so if you look at the previous 2 example, how the ester linkage is being formed, okay, you realize that the oxygen, one from alcohol, one from the acid. So what I'm going to do now is going to split them into half. Okay, so this is what I will do. And then I will realize that, oh, okay, this is definitely the alcohol. Okay, because it only has one oxygen, or rather it's a single bond. Okay, then this one, if you see double bond, it must be from a carboxylic acid. Okay, so the product is this. And if I break it and work backwards, I will have my ethanol. And then I will have my ethanoic acid. And to confirm your answers, you just need to draw the reactants. And then you realize that, yeah, okay, when these two react together, they will form that product. Okay, so this is what we call esterification. So let's recap what we have learned so far. Okay, so for today's lesson, we saw this new homologous series called carboxylic acid. Okay, and this carboxylic acid has a functional group called C double bond O OH. And this hydrogen here is acidic. It will form H plus. Okay, and then we also take a look at the full structural formula for the carboxylic acids. Okay, we draw methanoic acid all the way to butanoic acid. So the general formula is CN H2N plus 1 and the functional group is COOH. In this case, N starts from 0. Okay, N starts from 0 because the first carbon is already accounted for here. Okay, since it's an acid, it can react with carbonate, base, metal, and it's a weak acid. Okay, so the reaction will be reversible. Then we also take a look at why do we need to form ethanoic acid. Okay, so another name for ethanoic acid is vinegar. So we use vinegar for preservation. Okay, so it's formed because of the atmospheric oxygen or oxidizing agent. Okay, then the last reaction that we learned for carboxylic acid is esterification. Okay, with a functional group that is almost the same as carboxylic acid. Okay, so it's C double bond O, and this O is bonded to a carbon. Okay, so we finished this too. And the reason why we learned about the reaction of esters, okay, because they are commonly used to make food flavorings, perfume because of their sweet smell. Okay, so this is the end of the homologous series carboxylic acid. Okay,